Well, welcome back to the Block Talk, and in this session we're going to talk a little bit about the Ethereum Naming Service. And specifically we're going to talk about the details behind the scenes of how the naming service works, why it's important, why you should care about it, and we'll give a quick little demo about how you could take advantage of this and some pointers to some documentation for that. So to get started, the Ethereum Name Service, if you think about it, is really kind of similar to what we understand today as a domain naming service. And when you think about a domain naming service, you essentially have what becomes a centralized system because we have these root level naming servers who are going to own these domains, and then essentially there's a price set for specific domains in those subdomains. So the top level domains are controlled by a secure group, and then beyond that is people would purchase the ownership to own the names for certain ones. And then basically those get distributed. It is a kind of distributed database that gets synced across the world to a bunch of different database servers. And so basically in our traditional DNS, when we think about where are the points of inflection where blockchain might be able to help at, and what ENS is kind of set out to do is basically disrupt that a little bit from a couple different stances. So if we look at the screen now, the core components that make this up are the ENS registry, which essentially is a smart contract where you're going to basically register these different domains, whether it's a top level domain or something that's a little further down the domain in a subtree, in a nested kind of name. And these will just resolve to various addresses that will exist as part of this contract, this ENS registry contract. These obviously can have an owner. So you would have to have a set of keys, and you can digitally sign any transaction for I'm going to register a new name, I'm going to transfer ownership of one, and various things like that. There's also, you notice that the resolver is kind of decoupled. So along with the names, you can also specify a resolver. Now the resolver, essentially right now, you could be a smart contract, right? So inside the smart contract, you could essentially pick from multiple different resolvers that exist out there, depending on which ones you trust. So basically, if someone were to hijack this, they would have to modify each one of those. So that's kind of the resiliency built into the system, where we have this loose coupling between the ENS resolvers and the actual ENS registry of the names. To click down on that just a little bit more and look at what makes up the anatomy of one of these records, very similar to a DNS type record. So we have an owner, which could be an external account or smart contract, so a valid address that exists on the Ethereum blockchain. There would be the resolver, so again an address to a contract that's going to do the resolution for the name, and that really is mapping a human readable name to an address. So we don't have to remember the addresses. Very much like IP addresses to domain names we have today. And there will also be a TTL. So the TTL is the time to live for the record. These have a finite lifetime. And the way these work is the bidding system is not controlled by any kind of central service. So essentially, if you go in right now, actually, to resolve one of these names, you could say, or start a bidding auction, actually. So you can go check to see if a name exists. So if I wanted to check for blockchain.eth, if I went and looked, I can query the system. First off, I can query the blockchain and ask it, does anybody own this? If they don't own it and it's not in an active auction, I could start an auction for it. The auctions have parameters built around them, so there's a little bit of time there for other people to be fair, to allow them to bid on it as well. And essentially you're staking ETH. So you're using some Ethereum to basically stake and say, this is my stake in the game, that I'm not going to be manipulating the system to make it detrimental if I'm trying to mess with the system. And I'm going to stake this and say I'll bid this much. Now there could be a bidding process where someone else bids more, and then that process goes on until the time runs out. Whoever's the bidder, the highest bidder, then receives the record ownership. And then at any point they can transfer ownership to anyone else, or they can just hang on to it and use it. You can also tag other things along with this. We're just going to touch on the basics here, but you could essentially tag into like a swarm address where you can basically have other content. So when someone hits this thing from a decentralized application, you can have it resolve to things on IPFS or Swarm or something like that in a storage system where you can store much more data. But in this one, we're going to just show kind of the basics, and I'm going to switch over to my screen here right now and show you what we're looking at here. So what you'll see on my screen here now is essentially two panes. At the top here we have basically running against public Ethereum. We just have a little geth node running there in light mode. And what I'm going to do is just attach to this. So I'm just going to run, I have geth installed here. So I'll just do a geth attach, and I have RPC open on this box so we can get into it. And you see we're attached there, and basically we've already synced up because I had this running in the background here. There's a script that you can download that we'll put a link to so that you can basically take advantage of like some library functions. There's much more advanced libraries in Node.js and things like that, but we're just going to use a simple script here today to do some functions. So I just call it ENS utils, and again we'll put the link to this. This is not for production work, the script by any means. This is more for something interactive, so you can kind of work with ENS. So we'll give it a second. You see it loaded the script, and the first thing we can do is basically do a get adder, which is get address. And I have one registered already that I purchased. It's my handle on Twitter, and I registered this about a year ago. And if you do a get adder on it, you can see we're basically what's happening there is we're making a call. If you go look at the code in the script, we're going to go ahead and make a call into a smart contract there to get the resolver. So we'll figure out what the resolver is for windows.eth, and then we'll basically query that resolver who has implemented an interface that allows us to see that this is the address of the owner of windows.eth. So pretty simple stuff. Otherwise, we can do things like ENS owner, where we can basically, and we'll have to convert the name to a hash. So there's a convenience function built in there by the script guys. And basically from here, we can see that's the owner of it, and get adder is kind of the same thing. But what's cool is you can actually do things like the Ens Resolver. So you can go see who's actually been registered to resolve this name. And you can see that address, so it's a 01DA, a really long address. I went ahead and copied that over here so we can take a look at what we got there. So give me 1 second here. And I'm just in eScan. This is public Ethereum. And basically I just do a query for that. And you can see all these transactions. You can see these are public resolvers that are basically calling in here. So whenever we registered this, you can see a little bit of ETH. A transaction fee is applied in order to do those. And you can basically even look, because they do have the code uploaded, you can see how they've implemented the resolving function. So there's, like I mentioned, there's a specific interface that you need to implement in order to satisfy the bounds so that you can use these things to do queries, and people can figure out whenever they go to query for your name or your address that you could have a reverse resolver. You can see both of those. So this is just a really high level look at what's going on with ENS. And the reality is we're trying to build these more resilient systems so that we don't have any kind of centralization or single point that could be attacked. You can look on the internet at kind of DDoS attacks that have happened, and trying to kind of spread that out on the blockchain so that it's a much harder thing to pull off to kind of DDoS and attack someone's name. And so that's why I think it's important for people to understand some of this technology that's being built here on the Ethereum system. So thanks for watching again on Block Talk, and follow us on MSFT Blockchain. We have lots of other episodes out here, and thanks for watching.